They are basically high energy electromagnetic waves, and they are emitted by the nuclei that need to lose some of energy. This is the symbol of the gamma particles. So we need to write down few more properties of the gamma particles. You must be writing it down. Uh, they have they have least ionization ability. They have maximum penetration ability. Their penetration ability is maximum. They remain undeflected. They remain undeflected in electric field and magnetic field. So they are undeflected in electric field and magnetic field. They have the maximum penetration ability. They have least ionization ability, and they have high energy electromagnetic radiations. They can be stopped by what? They can be stopped by lead or concrete. It can be stopped by lead or concrete. So these are the respective properties of the gamma rays. And if these particles hit other atom, they can knock out the electron. And their use is that they can be used in killing the cancer cells or brain tumor cells and so on and so forth. Is this fine? People, shall I move on?
Yes, sir.
Next, this is the comparison of all the properties of the alpha, beta, and gamma. So, alpha particles की composition ये है कि it is carrying two protons, two neutrons. Its mass is four times of u. Alpha particle is a positive two charge, and its speed is roughly 0.05 times of the speed of light. Beta minus particles are actually electrons, and their mass is 0.0005 times of u. They carry negative one charge, and their speed is nearly equivalent to the speed of light, but it is lesser than that value. Likewise, beta positive particles do exist as well, and they are called as positrons. They have the same mass as that of the beta negative particle, but the only difference between beta negative and beta positive is beta minus is carrying negative one charge and beta plus is carrying positive one times of a charge, and likewise their speed in air is almost same. Gamma particles are electromagnetic waves. They have no mass, they have no charge, and likewise their speed is same as the speed of light. So they move with the speed of light the way they have been moving, right? So if you are asking about the last slide, you may just see it, Hassan. ये last slide है हमारी. जी, shall I move on?
Yes, sir.
Okay. So this was a summary of all the properties. So this is how all of the particles are connected with one another, or they can be compared with one another. So you must memorize all of these properties. The nature of the alpha particle is that they are helium nucleus. They carry two proton and two neutron. What are the beta negative particles? They are fast moving electrons. They are emitted from the nucleus. What are beta positive particles? Positive particles are antimatter of the beta negative one. They are the fast moving positron. इस particle को हम क्या नाम देते हैं? Positron, जिसको beta positive बोला जाता है. This is beta positive and one is beta negative. The fast moving positron is emitted from the nucleus. And what are gamma rays? They are high frequency electromagnetic radiations. What is the charge present on alpha? It is positive 2. On beta negative, it is minus 1. On beta positive, it is positive 1. And likewise, gamma is having no charge. Mass of alpha is equals to 4 times of atomic mass unit. Mass on beta negative is about 0.0005 times of atomic mass unit. That is equivalent to this much value. Similarly, beta negative is also having same mass as beta positive, and gamma is having no mass. Symbol for alpha is this, for beta it is this, for beta positive it is like this, being shown in front of you, and gamma का symbol ये है. Penetration, alpha is having the least penetration and they can be stopped by a paper. Beta are having mediocre sort of penetration power and they can be stopped by aluminium. Likewise, beta positive is also having very low penetration power and it can be stopped by aluminium. And gamma is having the highest penetration ability and they can be stopped by thick lead block or concrete wall. Uh, Alpha particle have highest ionization ability. Beta particle is having lower than alpha. Likewise, beta positive is also having lower than alpha. And the gamma particles are having the least ionization ability. So their range in air, alpha particle is having lowest, and the range of beta negative particle is greater, but beta positive particle is having pretty low range, and the range of gamma particle is highest around 20 meters. Their speed varies accordingly, so the speed of alpha particle is about like 0.1 times of the speed of light in air. Um, Likewise, beta negative particle, it is lesser than 3 into 10 power 8 meter per second. Uh, And for beta positive particle, it is also a bit less than 3 into 10 power 8 meter per second, whereas for gamma particles, the speed is 3 into 10 power 8 meter per second. So these are the respective differences between all of the particles, and mm, you must be knowing about all of these properties. Yes, gamma rays can be completely stopped by the lead or concrete. But if their thickness is less than 4 centimeter or 5 centimeters, so it is going to stop partial of the gamma rays, but might be majority of the gamma rays still can pass through. Ji, shall I move on?
Yes, sir.
Yes, sir.
Okay, next there is one example in front of us. So let's see uh, how to solve this question. The question says that there are three successive radioactive decays are shown in the diagram below. Each one result in a particle being emitted. The first decay results in the emission of beta particle. So there is one emission of the beta particle. The second decay results in the emission of alpha particle. And the third decay results in the emission of another beta positive particle. Nuclides W and Z are compared. Which nuclide of Z is formed at the end of this decay? So we have to tell us the final number of proton and neutron in them. So mind one thing, basically we should have been discussing this question after the study of alpha, beta, and gamma decays, but nevertheless it's not difficult. So let's discuss this example here. So see, when one of the parent nuclei is converting into a daughter nuclei, and if there is going to be a minus beta minus particle is going to be produced. So always remember the nucleon number stays the same. It means your here nucleon number will be remain as 237, but your proton number is going to be increased by 1. So this will be equals to 93, because in the case of beta negative, one proton is being produced. Then, when an alpha particle happens, your nucleon number will be reduced by 4, because it is alpha is having a number of 4 and 2. So 4 इसका nucleon number निकल गया. What is left at the back? It will be 233. And likewise, 2 is gone from its bottom part. So it will becomes 91. And likewise, when beta positive part is going to take place, so what is beta positive? Beta positive means that nothing is going to change in its nucleon number, but there is going to be a plus one removed from it. A positive particle will be, yani कि one proton will be removed from it. So it will becomes what? Z का जो pro nucleon number है, it will remain same, but there will be one decrementation of the proton number. So what is going to be the correct option in this regard? It is going to be 23390. Yes, people, is this understandable? The people, shall I move on?
Yes, sir.
Okay.
Yes, sir.
Next, we know during radioactivity, certain decays can take place. And those decays are what? The decays can be beta positive decay, decay can be alpha decay, decay can be beta positive particle decay, and gamma decay. What name I am just taking is that whenever radioactivity happens, either an alpha particle is going to be produced or a beta positive particle is going to be produced or a beta negative particle is going to be produced or a gamma particle is going to be produced, right? So whenever there is going to be a production of beta negative particle, you have to just memorize this at the moment. Whenever there is going to be a beta negative decay, it means that in any nuclear reaction जब भी बीटा नेगेटिव पार्टिकल प्रोड्यूस होगा किसी भी न्यूक्लियर रिएक्शन में, इन दैट स्पेसिफिक रिएक्शन इलेक्ट्रॉन एंटी न्यूट्रिनोज, एक और सॉर्ट ऑफ सब एटॉमिक पार्टिकल है, ये क्या पार्टिकल हम आगे चल के इसकी कैरेक्टरिस्टिक्स को पढ़ेंगे. सो देयर इज वन पार्टिकल गोइंग टू बी प्रोड्यूस व्हिच इज कॉल्ड एज इलेक्ट्रॉन एंटी न्यूट्रिनो. And how do we represent electron antineutrino? It is represented in this way: VE, E for electron, V for neutrino. And this bar at the top is representing anti-electron neutrino. And likewise, when there is going to be a production of beta positive decay, यानी कि जब भी beta positive particle produce होगा, यानी कि जब भी positron produce होगा, beta positive particle is called as positron. So whenever a positron will be produced, with the positron, there is another subatomic particle going to be produced, which is called as electron neutrinos. So, by the way, what these neutrinos are? Electron neutrinos are the subatomic particles जिनका ना तो कोई specific amount of charge होता है और ना ही उनके पास कुछ mass होता है. ये एक बाय प्रोडक्ट से पार्टिकल प्रोड्यूस होते हैं जिनका बहुत मिनिमम ना होने के बराबर mass होता है, बट उनके ऊपर चार्ज कोई भी नहीं होता. And they are also being emitted by the nucleus of the radioactive isotopes. So you have to memorize these two names in exam. You are going to be experiencing these names, that electron antineutrino will be produced during beta negative particle and electron neutrinos will be produced during beta positive particle. Is it understandable? So what is the representation of the electron neutrinos? VE for electron neutrino, and anti-electron neutrino is represented by VE with a bar at its top. Yes, people, tell me, is this fine?
Yes, sir.
Okay. So moving onwards to the next part, yes, we are just witnessing and we are saying that there during the radioactivity there is a production of alpha, beta particles. So it has been observed whenever an alpha particle is being produced, the energy values are in the form of discrete value, यानी कि continuous energy पैदा नहीं होती, एक small packets की form में energy जो है वो produce हो रही होती है, जिसको हम क्या बोलते हैं, that energy is in the discrete form, non-continuous form. Whereas when beta particles are being produced, it has been seen that during that radioactive decay, during that nuclear reaction, the energy produced is in the continuous form. This difference is to be keep in your mind. Last year, 1 to 2 mark question appear in your 2025 paper, that what are the particles which produces the continuous kinetic energy as a result of radioactivity. So they are beta particle. और ऐसा क्यों होता है कि बीटा पार्टिकल continuous energies क्यों निकाल रहे होते हैं? Because they are producing न्यूट्रिनोज. इनके साथ साथ क्या पैदा हो रहे हैं? न्यूट्रिनोज पैदा हो रहे हैं, जिसकी वजह से इनकी एनर्जी जो है वो कॉन्टिन्यूअस शेप में फॉर्म होगी. वेर एज अल्फा पार्टिकल जब भी प्रोड्यूस होगा तो एनर्जी जो है बस एक फिक्स अमाउंट में निकलेगी. कॉन्टिन्यूअस अमाउंट में एनर्जी या हर वक्त एनर्जी प्रोड्यूस नहीं हो रही होगी. So when the number of alpha particles plotted against kinetic energy, there are clear spikes that appear on the graph. So these spikes are shown that kinetic energy is not continuous. Kinetic energy is in the discrete form of energy. And when the beta particle is plotted against the kinetic energy, so we can say that beta particles have the continuous range of energies. So this is the distinguishing point between both, that during beta decay, there is a continuous range of energy being produced, and during alpha decay there is a discrete form of energy is being produced. These are the two differences which you should be knowing about it. और यहाँ से हमें पता चला था कि बीटा के क्योंकि continuous energy है, so this can be anticipated that it is all because of the production of neutrinos and antineutrinos. क्योंकि न्यूट्रिनोज और एंटी न्यूट्रिनोज कुछ नेग्लिजिबल अमाउंट ऑफ एनर्जी अपने पास रखते हैं. इज दिस फाइन?
Yes, sir.
ओके, मूविंग ऑनवर्ड्स. अब हम डिस्कस करते हैं अल्फा डिकेज बीटा डिकेज की इक्वेशन को. तो सबसे पहले, दिस इज द सिमिलर टॉपिक विच यू वुड हैव डेफिनेटली स्टडीड इन योर आईजीसी एज वेल. अल्फा डिके में क्या होता है कि अल्फा डिके के अंदर जब भी एक पेरेंट एलिमेंट है, यानी कि लेट से कोई भी एक एलिमेंट है, एक अनस्टेबल एलिमेंट है, उसके पास न्यूक्लियॉन नंबर ए है और प्रोटॉन नंबर जी है. फॉर इंस्टेंस इफ इट चेंजेस इनटू अ डॉटर एलिमेंट वाई, तो वो साथ में क्या प्रोड्यूस करेगा? एक अल्फा पार्टिकल भी प्रोड्यूस करेगा. और अल्फा पार्टिकल जो भी प्रोड्यूस करेगा, वी नो उसका जो न्यूक्लियॉन नंबर है वो है 4, और उसका जो प्रोटॉन नंबर है वो है 2. सो वेन एवर एन अल्फा डिके इज गोइंग टू हैपन, जो भी एंड में आपके पास एलिमेंट प्रोड्यूस होगा, उसके न्यूक्लियॉन नंबर विल बी सब्ट्रैक्टेड बाय 4 and proton number will be subtracted by 2. So you have to memorize this in the case of alpha decay. Whenever an alpha decay happens, the parent nucleus is going to get rid of two protons and two neutrons. And how they can be written in the form of equation? In the form of equation, when parent nuclei is converting into daughter nuclei, so in the case of daughter nuclei, the nucleon number is subtracted by 4 and proton number is subtracted by 2. So you can see this here in the equation as well. तो यहाँ equation में आप देख सकते हो, in the case of alpha decay equation, there is an element X which is converting into an element Y with the formation of alpha particle as well. तो अल्फा पार्टिकल में A में से 4 माइनस हो जाएगा, Z में से 2 माइनस हो जाएगा, and we are going to get the alpha decay. So this is an example of alpha decay. For example, we are having a polonium as one of the element which is having nucleon number as 212 and proton number as 84. It changes into another element, let's say Y. So and with an emission of alpha particle. When alpha particle was produced, you can see, okay, what difference we can witness in the nucleon numbers. In nucleon numbers will be decremented by 4, and what we can see the difference in the proton number. The proton number is decremented by 2. So proton number will be decremented by 2 and nucleon number will be decremented by 4. This is the distinguishing point between the parent nucleus and the daughter nucleus during the alpha decay. Gee guys, is this understandable? Yes, people speak up, please. Shall I move onwards?
Yes, sir.
Okay, there is an other example in front of us. This is the question being shown. Question says the radioactive nucleus, which is called as, let's say, radon Rn, it is having a nucleon number as 222 and proton number of 86. It undergoes an alpha decay, and this alpha decay happens into a daughter nucleus PO, right? There is a radioactive nucleus having a radon Rn. It undergoes into an alpha decay, and it produces some daughter nucleus PO. So we are pretty aware about this fact कि let's say अगर मैं इसकी equation लिखना चाहूँ, मैं इसकी equation कैसे लिखूंगा कि एक मेरे पास parent element था radon Rn, वो चेंज हो गया polonium PO में, and with that it produce an alpha particle. So alpha will be having 4 at its top and 2 at its bottom, and here it is 2 2 2, and here it is 86. So guys, can you let me know what will be at the top on the nucleon number and bottom of the proton number? Yes, can anyone tell me? Yes, anyone who can answer this? What is going to be at the top of PO and at the bottom of PO when an alpha particle is being taken out or alpha particle is being given out? Yes, so there is going to be, you're right, there is going to be 218 at the top, and there is going to be 84 at the bottom. So at the top, what we are going to get, it is 218, and at the bottom, there is going to be 84. So now in this question, it is saying which letter is showing the डॉटर प्रोडक्ट, यानी कि कौन सा ऐसा प्रोडक्ट है, कौन सा ऐसा लेटर जो पीओ को शो कर रहा है. तो अगर मैं प्रोटॉन नंबर देखूं, इसमें 84 है, और नंबर ऑफ न्यूट्रॉन्स कैसे निकालते हैं, 218 में से 84 को माइनस कर देंगे. सो कैन एनीवन टेल मी व्हाट इज द सब्ट्रैक्शन ऑफ 218 minus 84? Yes, can anyone tell me 218?
134.
Yes, it will be equivalent to 134. तो हम देखते हैं कौन सा ऐसा लेटर है जो 84 एज अ प्रोटॉन नंबर शो कर रहा है और 134 एज अ न्यूट्रॉन नंबर शो कर रहा है. सो व्हाट इज दैट लेटर? दैट लेटर इज सी. So answer of first part is going to be C. Is it understandable how you have to govern these questions? Yes. People, shall I move on? Hello. Okay, next we will be having beta negative decay. So what happens in the case of beta negative decay? So you have to memorize these statements because they generally do appear in your paper as well. So whenever a beta negative decay is going to happen, what is the meaning of beta negative decay? It means that as a result of radioactivity, a beta negative particle will be produced. तो जब भी बीटा नेगेटिव पार्टिकल, सबसे पहले हम देखते हैं उसकी रिप्रेजेंटेशन क्या है. तो बीटा नेगेटिव को आप इक्वेशन में कैसे शो करोगी? उसके टॉप पे 0 लिखा जाएगा और उसके बॉटम पे -1 विल बी रिटन. सो बीटा नेगेटिव डिके और बीटा नेगेटिव पार्टिकल इज अ हाई एनर्जी इलेक्ट्रॉन विच इज emitted फ्रॉम द न्यूक्लियस. और जब भी ऐसा होगा, तो इन बीटा नेगेटिव डिके, when a neutron turns into a proton, it emits an electron. और साथ में और क्या ये emit करता है? It also emits an anti-electron neutrino. राइट. तो अभी हमने पढ़ा है कि जब भी बीटा नेगेटिव डिके होगा, व्हाट विल बी एमिटेड? फर्स्ट ऑफ ऑल, अ न्यूट्रॉन विल बी कन्वर्टिंग इनटू अ प्रोटॉन. एक प्रोटॉन का इजाफा हो जाता है, और उसके साथ साथ क्या प्रोड्यूस होगा? देयर इज गोइंग टू बी अ प्रोडक्शन ऑफ एंटी इलेक्ट्रॉन न्यूट्रिनो, and plus there is a beta negative particle. So how its equation will be written? So let's say we are having an element X which undergoes a beta negative decay. सो उसके जो डॉटर प्रोडक्ट होगा या उसका जो रिजल्ट में एक एलिमेंट प्रोड्यूस होगा, उसका जो न्यूक्लियस होगा,
वाला आपने लास्ट टाइम
it will have the same as a nucleon number, और उसका जो proton number है it will be increased by 1, and with that there is a formation of electron anti-neutrino. With that there is a production of what? Electron anti. This is the representation of electron anti-neutrino. There's going to be a production of electron anti-neutrino. So we can see an example of this. Here we are having carbon 14. So carbon 14 changes into a nitrogen, for instance, 14 and 7. And we can see कि इसका जो न्यूक्लियन नंबर है दोनों का सेम है, बट प्रोटॉन नंबर नाइट्रोजन का एक बढ़ गया. Plus there is an emission of beta negative particle. With that there is an emission of electron anti-neutrino. So it's an exam part. In exam you are being several times it is going to be asked from your paper that while beta negative decay, which particle is being produced. So it is going to be electron anti-neutrino. Is this fine? So you must be knowing that in beta negative decay, neutron changes into proton with an emission of beta negative particle plus with an emission of electron anti-neutrino. Okay, moving onwards. Next, beta positive decay. So what is the meaning of beta positive decay? Beta positive decay. Okay, Afrinish, I can stay back on this. You can just write it down. Okay, I'm moving onwards. Next, we are going to see the beta positive decay. What is happening in the beta positive decay? It's the opposite of the beta negative decay. So in beta positive decay, one of the neutron converts itself into a neutron. So एक प्रोटॉन जो है प्रोटॉन turns into neutrons and it is emitting a positron with it. With an emission of positron, there is going to be an emission of electron neutrino. ठीक है, so you must be knowing that in a beta negative decay there is an electron anti-neutrino, and in the decay of beta positive there is going to be an electron neutrino. So you can see from here, let's say there is an element X, A and Z. It changes into a daughter element Y. With this it emits one beta positive particle. Let's call it as positron. What it is called as? It is called as positron. Plus this VE00 is representing what? It is representing electron neutrino. This is all you have to memorize everything, and these things do appear in your paper. So if we talk about the particle